Hi everyone, welcome to another practice problem walkthrough video by physacademy.com. In this video, we will discuss almost all of the important notes we need to know about Young's double-slit interference and single-slit diffraction equations. Below is an image of the fringe pattern produced by two identical slits and light of wavelength lambda equals 600 nanometers. The pattern is produced on a screen 1.0 meters from the slits. Using the provided scale, determine the separation between the slits and the width of one individual slit. Explain your reasoning. A. The separation between the two slits. B. Width of one individual slit. First, let's start with analyzing the given double-slit pattern. A double-slit pattern is the overlap of two patterns. Pattern 1 forms the small fringes, and we use Young's double-slit experiment equations to analyze it. Here m is the fringe number with respect to the center fringe. M equals 0 is the center fringe, m equals 1 is the next bright fringe, and so on. As you see, m equals 3 is right at 1 centimeter from the center line, therefore we will use m equals 3 and its corresponding y m equals 1 centimeter for our calculation later. Lambda is the wavelength of the light source. Here, lambda is given as 600 nanometers, which is the wavelength of the orange color. L is the distance between the double slits and the screen, which is 1 meter in this case. D is the distance between the center of the slits, and we are going to calculate it in part A. Pattern 2 forms the overall intensity profile, and we use the single-slit experiment equation to analyze it. For the single-slit intensity profile, we only have one equation that gives the location of the areas where this overall intensity goes to 0. In this case, P equals 1 corresponds to the first region where intensity goes to 0 at about 2 centimeters from the center. So y P1 is 2 centimeters. P equals 1. Lambda equals 600 nanometers. L equals 1 meter. And we are asked to find the width of the slit or A. For part A, we use Young's double-slit equation for the bright fringes. After rearranging the equation for calculating D, we have the following equation. Remember, D is the distance between the center of the two slits on a double-slit card. Then we plug the given values into the equation, and we get 180 times 10 to the power of minus 6 meters, which is the same as 160 micrometers. Let's check the units really quick too. On the left-hand side, D is in meters. On the right-hand side of the equation, we have meters times meters divided by meters, which equals meters, so we are good. In part B, we are asked to calculate the width of the slits. For this, we use the single-slit equation and follow the same steps as part A. A, or the width of the slits, is 30 micrometers. Let's check two things. First, always make sure the width of the slits is less than the distance between their centers. Otherwise, physically having such a double-slit card in the real world is impossible. Second, we check the units, and as you see, we get meters on both sides of the equation, so we are good. Thank you very much for watching this video. Please check our website, physacademy.com, or our YouTube channel for more practice problems. If you found it helpful, to support our work, please consider subscribing to our channel.